Hello, everybody. If you're taking part in the Flexible Fund speed round, please could you come to the stage now and we'll get started in just a moment. Thank you. Hi, thanks everybody. Welcome back. Hope you have time to have a chat, ask some questions to people, get a coffee and sort of feel energised. This is the Flexible Fund speed round, so quite an unenviable task of keeping 5 academics to 2.5-minute descriptions of feasibility studies that they conducted over the last couple of years that were funded by the CE Hub. So the Flexible Fund, I'm going to get out of the way quite quickly so we can hear more about the projects, but the Flex Fund offers the CE Hub and the NISA programme an opportunity to fund some daring projects that hopefully sort of generate kind of interesting insights and have potential for great impact. We've just closed the last funding, so all the Flex Funds are finished now for the programme, so we get to sit back and hear about the projects that have already happened and see the ones that unfold. Like the other sessions, we don't have time for questions necessarily, so please keep them for the lunch break and for later sessions. And just for the members on the stage, we have a 2.5-minute clock up there, and I do have a little bell that I'll just ding at 30 seconds, just so that you aren't distracted by the clock necessarily. So when you hear the bell, if you start to sort of come to a close, that would be fantastic. And I'm going to advance through the slides for you. And I think first up we have Anna.
Hi, hello everyone. My name is Anna Itter and I'm from the University of Leeds. And today I'll be talking just a little bit about my feasibility study that I've conducted within the umbrella of the CE Hub. I was focusing on sustainable infrastructure construction and in particular looking at an alternative source for calcium carbonate, and the material we selected was eggshells and seashells. Can you just click? I think it's animated. Yes, one more. Yeah, thank you. So you have a visual cue there. So basically, why did we thought about using seashells and eggshells? Well, there are quite a lot of large volumes produced annually in the UK, and currently the practice is that most of it is going to landfill. However, if you look at their chemical composition, they are really a good resource for calcium carbonate. And in fact are an alternative for the use of quarried limestone that is now the raw material that we use for lime manufacturing. And the way I got involved is that I'm actually, my background is geotechnical engineering, so I'm more interested in improving the behavior of soils, and in particular the marginal soils that arise in large earthwork projects, such as we have one coming up, the HS2, and other types of infrastructure projects where there's also a lot of poor quality soils that are typically landfilled. So the project had the aim to deal with these two challenges, enhance performances of these marginal soils by using a low carbon binder. And the way we achieve that is by manufacturing lime using eggshells and seashells. Now, note that the lime sector is actually quite a large sector, and we only focus on soil stabilization for two reasons. First, because the market demand is relatively small, and second is because eggshells and seashells come with a small percentage of organics. So the intention was that we would reuse this material. And just to give you, we just have a few seconds left, just to give you a little bit of an overview, it does work. So the chemical composition of these limes are very comparable to that of limestone-based lime. And not only the performance is as good in the seashell lime, is actually better than the limestone lime. So that means that it actually works. Thank you.
Thank you. Next up we have Libby, and this hopefully is your slide.
just get through it otherwise. So this is a project that joins up some of the work that we've been doing in the Circular Chem Centre with another project that we have with RAF Learning, which is called the Vital Living Lab. So we have a company that we're working with called Wastefront that are developing a large tyre recycling facility in Sunderland where they're going to be recycling 80,000 tonnes of tyres a year. They have a market for the oil but not for the carbon black. So we saw that as an opportunity for us to have a look at whether or not we could make a more recyclable and more sustainable source of materials for our solar cells that we're working on with the RAF. And then, of course, we're joining up net zero with energy and security, not just of our country, but also of supply of resources. So, just keep clicking. So, what we've done in this project is my postdoc at the front, Susana Iglesias Forres, has been taking the recycled material from Wastefront, formulating in ink, which we then print as a major component in our solar cells. Then we infiltrate this stack of materials with a salt, which is known as lead halide perovskite. This self-assembles in the stack, and then we then test it to see its performance. And great to our surprise, this actually performs better than the virgin material. So we then had to do some quite complex analysis to find out what's going on, and it turns out that there are certain characteristics, chemically and mechanically, of this material that makes it perform better in a device. And then we take this to our solar testing facility outdoors at RAF Learning, where we can see how well it performs under UK sunlight conditions, collect data on that, and at the end of the test we can then strip out the components and then reprint them into a stack and then test the performance again. At this stage, we're now doing some long-term stability studies and looking at the recyclability of the system, and then we're going to be using our Vital framework to do the life cycle assessment and carbon saving calculations to demonstrate the potential for this material. And we secured further funding from the Impact Accelerator and directly from Wastefront to continue to look at more opportunities for optimising this system and others.
Amazing. Thanks very much. So next up we have Lillian, so hopefully this is your slide.
Thank you. So I'm here representing the University for the Creative Arts, and I will introduce briefly the background to the project and also present some of the progress to date. So cricket is the second largest sport and potentially one of the most gear intensive. However, the sector has generally been slow to take on environmental and sustainability concerns. Previous research conducted by the Centre has identified that these sustainability initiatives focus primarily on the wider impact of climate change on the game, impact on the venues, facilities and grounds rather than on the gear. So this project, the Circular Cricket Gear Project, focuses on exploring potential strategies to maintain the value in cricket gear, so products, components and materials in the economic and social systems, as well as exploring material innovation. The overall aim is to develop a lab-based prototype by the end of the project. So far we have employed a series of physical and online innovation workshops, expert interviews, surveys, life cycle analysis, as well as structural and mechanical material testing. This has overall generated a common understanding of circular economy concepts within cricket gear amongst project partners and stakeholders. It has enabled the pre-selection of 4 potential circularity strategies for cricket batting pads, which include designing for disassembly, repair and reuse, as well as identifying materials and components for material substitution. And also, the life cycle analysis have highlighted materials and components with the highest environmental footprint that will be considered for further material innovation and also strategies for recovery and reuse. As for the next steps, we plan to conduct a further innovation workshop to explore further these pre-selected circularity strategies and produce a functional prototype for a batting pad. that will be tested with players. So thank you. And happy to discuss this further over coffee later. Thank you.
Hi everyone, my name is Saurabh Goyal and I'm a professor of manufacturing at London South Bank University and also Associate Director of the PSRC Network Plus in Digitalized Surface Manufacturing. So through this project we have taken an ambitious attempt to take one of the key ingredients of construction associated waste in trying to upscale the manufacturing and produce a value-added product. And the real motivation of this project actually started from one of the publications that is shown here from Professor Petya Hopkinson, who actually showed that how a lot of value materials actually get into landfill and lose their value as they are never recycled, and therefore we lose the idea of circular economy and enter into linear economy. And so the idea was, can we take one of the construction associated waste called a cement bypass dust waste, which is associated during the production of cement. So almost 12.2% amount of the cement bypass dust waste is generated as a byproduct of cement production. So what we wanted to do through this project is to actually take the cement bypass dust to process it through the unmatched capabilities of atmospheric plasma system thermal display manufacturing facility we have at London South Bank University, to process this dust through the process of thermal display and see what type of coating, which is a thin scale deposition material, can we generate. So we started by collecting the dust, we sieve that through, and then we fed it through this 5-axis robotic system through the plasma gases. And as a product of that, we got the finally finished coating version that is shown here that you can see. And what we feel like after doing the initial analysis, that this type of coating could be very useful material for repair of chimneys, refractory products and ovens, which are seldom repaired. And that's where we think the impact basically goes as we go on expanding this feasibility study further. That's it.
Oh, amazing. Extra points for time. And finally we have Kate.
There should be a video. Okay. So I'm Kate Franklin. I work at TWI, so I'm not an academic. It's a 100-year-old research organisation, and we used to be called the Welding Institute. Obviously, we focus on welding. So we do lots of welding, predominantly metallic components. I have to say I'm not used to being in a room with so many women. That was a joke. And I'm not an expert in timber or the circular economy. And so I think you're wondering, why on earth is this person here today? So we've been looking at welding wood. This is meant to be a video of welding wood. And we've been doing a CE Hub project where we've been doing something a little bit different. So we've done some historic work where we've looked at welding solid, virgin, hard woods. And this project we've looked at using repurposed material, so something that's been taken out of potentially demolished buildings, for instance, and rejoining it using a linear friction welding approach. So what is wood welding? Well, what essentially we're doing is rubbing the two components together under pressure and a certain frequency and amplitude, and hoping that it joins together. What are the benefits of that? Hopefully that it's extremely quick, and also that we're not adding any additional material into that joint. So we're just using the wood as two single parts. So there's no glue, there's no other additives, it's not in a kind of special environment or anything, there's absolutely nothing there. Which is really good for the recyclability of the product once it's been made as well. So it's quite a small project, but what we've been able to do is long welds that have never been done before, so 400 to 400 millimetre long welds, and also we've been able to show that we can join this recovered material. And we're now doing some additional work with UCL for them to analyse the results of those. Thank you. I've got some samples as well.
Amazing, thanks everybody. It's not, it's super difficult to distill all of this work into 2.5 minutes. So there's so much more to say. So if you have questions or just want to find out a little bit more information, please feel free to approach and spark up a discussion. But thanks very much. And that's the Flex Fund lightning round.
Great, thank you so much. So our final panel from the CE Hub today will be led by the wonderful Alex Lake, who is our Sector Business Development Manager. You'll notice that sector is spelled with CE. Very good. And she'll bring on her panelists, and they'll be talking about, like I said, the healthcare sector. So welcome.
Right, hello everybody, Alex Lake, thanks for introducing me. We're going to try and compress this session because Tom has a meeting at 1, so if you see him walking off, I don't think it's about anything I said, it's just because he's got to leave. So I'll tell you a little bit about Sector Project and what we're doing, then we're very quickly going to work on to our panel members here who are in the hot seats, which are probably quite warm by now, and I will be asking them a series of questions because this is meant to be the medical technology section, and I'll tell you what the connection is between the two. So the Sector Project within the NICER programme runs for the final 18 months of the programme, and it builds on all of the knowledge and the data and the materials research that you've seen in the room today and that you've seen in the centres and everywhere where you work. So we're moving from this whole materials research section into and towards a focus on how the circular economy can be integrated into whole sectors. We haven't got long to do it, so it's going to be a fairly light touch, but we're in the process of selecting 5 sectors to work with, and our first sector is the medical technology sector. We're working with private product manufacturers and designers, the NHS and government on this project, so it's a really good collaboration that we are about to get stuck into. So I will introduce, in fact, I'm going to get our speakers to introduce themselves, say a little bit about who you are, starting with Tom. If you could introduce yourself and then say a little bit about what drew you to start working with the circular economy in your work. What fired you up? Okay. And then on to Tanko, and then on to David.
Yeah, thank you. I'm Tom Dawson. I'm a medical technologist clinician, originally trained in emergency medicine, graduated about 30 years ago. I'm the founder of Revolution Zero, which is a circular economy medical textile organisation. We do the whole system, which we'll talk about in a bit later. And in one word, what drove me to this is anger. I'll leave it at that.
Good handover. Sanka Dimov, I'm a senior net zero delivery manager in NHS England, and I lead on the decarbonisation of our supply chain within the Greener NHS programme. And what was the question? What drove us? The economy in particular. So perhaps a little bit of anger mixed in there, but I think a lot of it is just. I think the circular economy presents a really exciting opportunity for a really broad benefit. So it's not just net zero, but it's also, we can see lots of instances where it also brings a big cost saving, or there's a substantial material waste saving as well, or there's a benefit to patients. And I think, and also it can increase the resilience of our supply chain. And so there's just such a broad range of benefits, and I think that's what makes it really exciting for me.
Great. how about you, David? This is David Watty.
Hi there. I'm David Wathy. I'm the Deputy Director for Supply Resilience and Engagement in the Department of Health and Social Care. I guess my interest in circular economy really stems from, we've come at it very much from a sort of, initially from a resilience angle, and our experiences over the last few years, particularly with the challenges of COVID, but not necessarily the direct response to COVID as much as the response to a lot of the sort of collateral sort of fallout of COVID and the disruption that that's had to sort of global economic models which has affected supply. It's certainly shone a light on the vast volume of materials that the NHS relies upon, particularly in terms of medical devices, to be supplied on a continual basis because of the extensive use of single-use devices, a lot of which are manufactured outside of the UK. And so when we start to think about how do we address this sort of resilience challenge, how can we be more resilient either from major shocks like pandemics or for some of the sort of shocks that will come to the system, and the Russians' invasion of Ukraine being an example, that have disruptive effects on our supply. How can we make that supply chain more resilient? And certainly looking at the case of sort of single use, to be able to change that model to increase levels of reuse, remanufacture or materials recovery will certainly make us more resilient going forward. It also, though, presents an opportunity, I think, for the medtech sector in the UK to increase capacity, capability, jobs, and develop sort of skills in this area for the UK medtech sector, but also the UK economy as a whole.
Thank you. Right. So when I circulated the questions earlier, this question was actually about passion and identifying, what was the passion that drew you to the circular economy. And I got two answers which were about anger and one about fear, I would say. And I mean, that's passionate, isn't it? We've got to act on this, and this is what's driving you. And I'm sure you've moved on from those initial responses because you're actually doing something about it. So I just wanted to ask Sanko, you're very, very deeply into the net zero and the greener NHS agenda now. So we know that the NHS is signed up to delivering net zero, as are so many other government and other sectors. And we know circular economy is very different to that. Not very different, but it is another aspect of what we need to plug into. How are more circular concepts being integrated into this established commitment and the established networks that go with it?
Yeah, so I suppose it probably helps to think about our approach to decarbonisation or decarbonising the supply chain, and it kind of there's two sides to it. And so the way you could split that is supplier side action and demand-led actions. And so the circularity really fits within the latter. So looking at the way that what the products and services that the NHS demands or that it buys and uses, and how can we shape those to be more aligned with the net zero future that we're aiming for, and to align with all sorts of other different mandates and aims about material waste or just efficient use of resources. And so the way that it fits within the programme is on that demand side. And just before I sort of say a little bit more about that, I just wanted to say about the supply side, because I think it was Kedar who mentioned active procurement earlier. And so when we look at the split of how our emissions are, we've got about 3,000 kilotons of carbon which is attributed to the products that we use. But the much more significant part of that actually comes from our suppliers themselves and the way that they operate and the way that they provide those. And so what we've got on the supply side is a series of commitments which you can find on our supplier roadmap, which outline the kind of changes that we need our suppliers to make to achieve that net zero future. And one example of those is, for example, All procurements over £5 million per annum will require the supplier to provide a carbon reduction plan for achieving net zero by 2050. That's the predominant focus of the programme, is to really get everyone on side and working towards that common goal. And once we've got that common goal that we're working towards, then we can really factor in particular like circular economy interventions, such as, for example, David mentioned the reduction of single-use devices or single-use equipment. And so once we've got suppliers aligned on this net zero agenda, then we can start to think, how can we work more closely together to achieve a system which procures products in a way that is aligned with those values.
Okay, I'm going to ask the same question to you, David, but in a slightly different way. So, Sanko's talked about carbon reduction plans, and we all know about them. They're fully integrated now. But you're about to embark with your 60 members of our new project on the medical technology circular economy project that we're doing within sector. Do you think it's going to be possible for us to integrate materials reduction as a metric into how you purchase items for the NHS?
I'd certainly say I think it's possible. I think it's probably essential as well, because it underpins the justification for looking at circular economy as a way of enhancing resilience. I mean, within our medtech strategy, we've identified the importance of material security and efficiency, as particularly with some of the changes we've seen in global economic structures and geopolitical relationships over the last, even over the last 12 months, let alone the last 2 to 3 years. And so I think it will become increasingly important we focus on materials and material efficiency. I think to be able to measure that and to get some understanding of that is fundamental to the case for change, because it is going to be a substantial change for an industry that's spent 40 years moving away from reuse towards single use for infection control reasons. There have been other, favourable wins which have made the economics of that attractive as well to a health system which is always under financial pressure. So I think to be able to make that case for changing away and shifting that direction of travel, which is substantial, we have to be able to put a convincing and evidence-based argument as to so that people can understand the benefits of making what is quite a sizable change, and to overcome that, if nothing else, the inertia for change.
That's great, thanks. And I mean, same question to you, Tom, that from a very practical, I've done it now type point of view, you've taken a product from start to finish using these principles, and I wondered if you could talk about your journey with your decontamination unit. Tom's with Zero Revolution. Tell us about what you've done on a very practical level with your medical textiles.
Yeah, certainly. In talking to both the other speakers as well, so we talked about decarbonisation and also some of the concerns around, for instance, infection control. It's absolutely critical that we have the highest standards if we're looking at reuse. So what we've been doing is essentially creating the enabling infrastructure for reuse, using 2023 state-of-the-art materials, builds, design processes, people with actually combined team, centuries of experience. There's people who've got a lot of experience in reuse of medical textiles. They used to be the norm 30 years ago, but it's getting those people and bringing them back. Some of the people in our team have come out of retirement to help save the world, and that's out of love, not anger, just to be sure. That's been absolutely critical, but all the standards, all the structures and everything in place, but at the same time making it more effective, more sustainable, and also more economic. And we've managed to nail those three things. We're now rolling that out operationally and at scale.
Great, thank you. So my next question is about patient safety, because nothing gets done in the NHS or approved unless it's safe for patients who use it. So I'd like to ask Sanko, what opportunities does the circular health economy present for patient outcomes and staff or social value?
Yeah, so I think probably the examples that come to mind are related to PPE, so personal protective equipment, and we can achieve sort of patient benefit or staff benefit through both reusing materials or through reducing the use of this equipment as well. And so if I just give a couple of examples of the opportunity presented by, for example, reusing. So throughout the pandemic, a lot of eye protection had to be worn, and particularly in surgery as well, where I forget the word, or the opacity or the quality of the lens makes a really big difference to a surgeon who's looking at a very fine sort of setting, very detailed, like an attention to detail is really needed, which can be sort of obviously impacted if the lens quality isn't high. And if we are procuring a huge volume of products on a single-use basis, obviously and naturally the quality of the product that we can afford to procure is diminished. And so if we were to introduce reusable eye protection, for example, we're able to procure a much greater quality product and design it specifically for the use of surgeons, whereas maybe typically when we're buying at that level of volume, we're buying glasses which were initially developed for the construction sector, for example. So that's one example. I'm not sure, other people might have seen, for example, the P3 masks, which are the sort of more high degree filtration masks required to be worn when they're used on this single-use basis, or the products that were being procured were sometimes leaving heavy bruising or marks on people's faces, as well as not always fitting people's faces the best way because they were developed in a very generic way. And so again, if we were to use a reusable product, we're able to cater that much more specifically for the people who are using it. And in both those settings, derive better patient outcomes because the visual comfort or the breathing comfort of the clinician is improved. And an example for the reduction of use might come from the Great Ormond Street Hospital glove campaign. And so when glove use is performed in line with best practice, actually we use a lot less non-sterile gloves than people would anticipate. And that's because hand washing is actually often the best practice. And so the overuse of single-use gloves has led to severe dermatitis in a lot of clinicians' hands. And so that's an example where if we were to reduce the use of these products, as well as saving money, we're leading to better outcomes for staff.
Okay. Did you have anything to add to that, Tom?
I think around the safety stuff, I think echoing some of Sanko's comments, but you can actually make it much better quality. And I often use the analogy of a pair of really nice handmade shoes as opposed to something that's been made very quickly offline. They can last for years and actually improve overall. We've certainly found that gowns and also surgical drapes preferred by the people using them. There's certain other things which are from a chemical perspective. So you're using long monofibers. They're less likely to produce microfibers. Microfibers can get into wounds and create infection. Something called the drapeability coefficient, which I expect all of you to drop at a dinner party on next Friday night. Drapeability coefficient is how well something hangs. By having something hang very well in an operating room, you decrease the airflow, which decreases the chance of infection into surgical wounds. So all these things make really good sense. As well, you can have it processed on-site, under your control, or close to on-site, so it can be very easily audited and so patient safety is absolutely critical.
Great, excellent. So now we move on to enablers, our keyword. David, in moving towards a circular health economy, what do you see as the key enablers to adoption?
I guess there are many. I think certainly to start, I think is provision. And when I say provision, it's making sure the industry is sort of geared up to actually provide products and potentially services as well that support that circular economy. Part of the enablers of that are ensuring that we've got a very clear regulatory framework and pathway, and that framework and pathway enable circular economy. I think as the regulations stand in the UK at the moment, and I think that exists for medical devices, but some of the feedback we've had in our engagement with industry is some more clarity around that. And there are some related areas of regulation, particularly waste regulation, where it's currently ambiguous. So I think being able to make sure that we have a clear regulatory pathway. I think one of the other key enablers is design, and it links into that provision of product. Actually, our products being designed with circularity in mind. And at this moment in time, as I say, the trend that we're trying to reverse is one which is where design principles have been based around single use. And a lot of that is for economic reasons, as well as what would be sort of proposed as sort of patient safety reasons as well. So I think that's a key enabler, that we start to get that design philosophy into suppliers, because the time scales, the gestation periods from the point sort of design to product being placed on the market are so much longer in healthcare, because of the body of evidence that's required to sort of prove the product is safe, to get through the regulated certification processes to place products on the market. So the earlier we get that design process started, the better.
So the flip side of that is what challenges do you see in trying to get regulation moving on this?
I don't think regulation is insurmountable. As I say, I think in the UK we have a reasonable position at the moment. I think it can be improved, and the flexibilities that one of the flexibilities that having sort of independence over our own sort of regulatory setting in medical devices is a positive in that area. I think in terms of some of the sort of key challenges, I guess if you sort of flip it from the provision side, I mean, there are challenges with industry to actually get them to move away from what's been an incredibly, and continues to be an incredibly lucrative model in single use. I think if you look at it from the demand side, and I think there's a lot of work we need to do with our colleagues in the NHS and with the clinical communities, to develop that sort of confidence around some of the perceived risks of reuse or remanufacture. I think also to try to sort of identify what are the rewards for this. I think there's been the economic balance has very much sort of shift towards sort of single use, when you could readily access cheap materials, readily access cheap labour, readily access cheap logistics. We've seen a change in those markets over the last 4 or 5 years, those dynamics. And so I think it's starting to sort of build that sort of case of what are the rewards for people to change. And to overcome that inherent inertia that everybody has, sort of to making what in some ways can be quite substantial systemic changes to practice, to infrastructure, to the sort of skills within the workforce. They're major change projects, and to embark on that, there has to be a significant enough reward.
Thank you. Do you have anything to add to that? Enablers, challenges, Tom?
So I think enablers, the two positive enablers are, one is people. So you've got 1.3 million people working for the NHS. 93% want the NHS to be more sustainable. It's a big driver, and we get so much pull from what we're doing. The other positive enabler is partnerships, and we've already talked about collaboration or communities working together. absolutely critical. People have to throw down the business models of competition as far as that goes. So partnerships working together. I'm going to keep on the alliteration theme here, but another enabler was the pandemic, obviously, which has really forced us towards circular economy. Then there's Putin, and then there's petrochemical crisis. So you've got those things that all come in together, and then moving away from that, we've got geopolitical instability. So what talking about some of the things we worry about, the supply chain resilience, it's lacking. The hyper-convenient global just-in-time supply chain no longer works. It's no longer fit for purpose. It's been supporting the linear take, make, waste model for a long time. It's no longer fit for purpose. Big enablers for us.
So we have the burning bridge. We're ripe for change.
Yeah, absolutely. I can touch on areas now if you want as well. Or
yes, why not?
So again, barriers. I think again hitting along. So policy is a barrier. It still has to be tweaked somewhat, and with that, procurement. So new models of procurement. We're actually looking at procuring system solutions rather than siloed things. So looking at the full thing. Really needs to come out. So looking at the full circular economy model, not just the cost of the product, which typically is a silo procurement thing, but the cost of the waste. What's the local return on investment value, and what's the value of actually having transparency and accountability in your whole supply chain? Adding that all up into a circular model where it's much easier to capture that and take it forward.
Right. And lastly, Sanko?
Yeah, there's not too
anything to add that these guys haven't touched on?
No, I think I'd mostly just want to agree with everything that was mentioned so far, and just to add to the point that Tom made and you said earlier about passion, is that I think throughout this whole project, the thing that I've found by far the most moving is every time that you engage with clinicians in whatever their particular focus areas or wherever they are in the country, you meet people who are pushing sustainability over and above their designated work, and I'm sure everyone will be well aware the clinicians across the country are very busy anyway, but when you meet someone who's developed a sustainable approach to anesthetics or to knee surgery or whatever it is, and they've just done that in their free time out of passion, that is such an incredible enabler that it would be impossible to put a value on. And just the other thing that I would add is that everything, all the barriers and enablers that have been mentioned so far, there's such a huge degree of interdependence across all of those, and we find, if we were to make a positive change in procurement, it would depend on there being infrastructure in place to support a supplier to transition to that, and so we're constantly having to measure incremental changes and to make sure they're balanced so that they're mutually supporting each other, and I think that's maybe one of the bigger challenges. And to enable that, the other thing is standardization. And so, what Tom mentioned it earlier, but one thing Revolution Zero have been incredible at is taking a space where there isn't a defined set of standards for quality, which is the reuse of gowns or surgical textiles, for example. There are standards obviously that exist, but actually developing those further. And what needs to happen in almost every area is for those standards of quality assurance to be adopted, not just across the country but internationally as well, because a lot of our suppliers work in a global setting, not just in the UK, and even the way that we measure the environmental benefit of something isn't necessarily standardized. And I think there'll probably be a lot of people in the room are familiar with LCAs, and there's a lot of different approaches or assumptions that can be taken when undertaking those. And so standardization, I'd say, is one of the big barriers.
Great. Okay. We still have a bit of time, Tom. You don't need to run off just yet, do you?
No, I'm actually fine for the whole time.
Great. So I have a question about case studies. David, I wanted to ask you if you could give us some examples of cases where circular products exist but are not adopted by the health system.
I think it sort of comes back to the sort of point I was making around challenges of, from the demand side, to actually ensure that that demand. I mean, I've sort of touched on, circular economy products, and one of the first sort of that came was sort of probably going back about sort of 6, 7, 8 years ago, and a company that was very much looked to bring remanufactured, minimally invasive surgical devices. That this is a market that exists in the US and has done for 20, 25 years, of taking product that are placed on the market as single-use devices, but taking them in, disassembling, replacing worn components, reassembling it in a thoroughly sort of sterile and sort of aseptic manufacturing unit, and then presenting that product as effectively as a new product back into the market. It's a successful business model in the US. They tried to bring that to the UK, and I think certainly that sort of scepticism over a product that had been remanufactured. And there was a lot of, while there was interest, there was a lot of convincing and evidence that needed to be provided around that process, to the point that it almost sort of ground to a halt. And I'm glad to see that there is a different supplier is now sort of taken on that mantle and is based in Europe and has been able to sort of make more progress in the NHS over that 6 or 7 years. But I think that issue still remains, and I think convincing people that reusable or remanufactured devices can be as good, and as these guys have already pointed out, in some cases better, far better than the single-use alternatives. We've also had more recent examples, I know, of one supplier that's sort of actually starting to roll out equipment for anaesthetic gas capture, but they've sort of run into difficulties around F-gas regulations and the classification of the for me, if it's the active pharmaceutical ingredient product that they're capturing, and whether you class it as waste or not as waste. As soon as you class it as waste, they've run into sort of a forest of sort of liability and sort of waste regulatory complexity, which has sort of at this moment in time, has sort of really undermined some of the economics and the commercial viability of that. And I'm sure there are ways we can work that through from a sort of regulation and policy process, but because what they are doing is fundamentally the right thing. But that's another example we've had again is of a product that's successfully been placed on the market in the US as a remanufactured market, actually by one of the largest medical device OEMs in the world. So good to see the large sort of global corporates starting to make sort of steps in this direction. But in terms of looking at bringing it into the UK market, the big barriers for that company have been there's a lack of infrastructure and logistics to support that recovery of materials, but also then the infrastructure to process or remanufacture those products close to the point of use. So their model would have relied on shipping it all the way back to the US to be remanufactured to come back, which again undermines the economic viability of it. But I think that last point sort of comes to where we see the big opportunity for the UK medtech sector and the UK economy in terms of sort of growth is that for circular economy models, in particularly medtech, probably in many other industries, to be most efficient and to be viable, we ideally need to build that remanufacturing or that decontamination capacity and capability close to the point of end use in the UK, which, if you think that we spend on average about £10 billion on medical devices a year in the NHS, even if you can take a small proportion of that to become regularly reused or remanufactured, you can divert a significant amount of that spend away from going offshore into overseas economy to circulate that, even if you do it at the same cost within the UK economy and the UK medtech sector.
Right, thank you. I'm going to leave the last question because we have just over 6 minutes left, and I wanted to give everybody the opportunity to ask questions of these guys while they're here. So is there anybody out there who would like to ask a question? Any hands up? I'm not seeing any hands up, so I'm taking that as no. Tom, David, Sanko, you've been the dream team. Thank you very much for coming up here and telling some really interesting stories. That is fascinating. I'm very excited to start working with all of you at the end of June, and our other 60 participants on the MedTech scheme in their 6 working groups. And that's just one of the sectors we're going to be working with. We're looking for the other 4 at the moment and trying to nail down which ones we're going to try and tackle next in our 18 months that we have. Thank you very much. Thank you.
Thank you.
Well, thank you very much. That draws us to a close of this morning's session, and hopefully you've gained just a bit of an insight into some of the work that we're doing across the NICER programme that's cutting across many different disciplines, and obviously working with lots of different partners in business and government to develop those really important whole system solutions. I'm going to hand over to Peter for a few concluding comments, and then a bit about what to expect over lunch.
I'm not so sure the concluding comments. I thought I'd better come on stage in case you thought Fiona and I had fallen out. But we do work together very closely and split roles. But I was just reflecting on Rob, if Rob's still in the room, about the origins of this programme. And Fiona knows this. So the discussions about NICER first started in about 2016, 2017. So it's pretty amazing to think how far it's come since then. And one organisation that we haven't mentioned this morning, which I think should be mentioned, is DEFRA. Okay, so DEFRA were very instrumental in the formation. And I think what you've gathered from this morning's event is the strong emphasis on impact and outcome. So for an academic research programme that comes through UKRI, there's a really, really sort of high focus and priority on making sure that the work that we do, the research that we're doing, has impact on the ground with industry, with policy, and with civic society. And I was reminded about some of the people who were responsible in the early days, so people like Sir Mark Walpole, Sir Ian Boyd, and someone who I'd forgotten, but I was reminded about. You might have heard of him, someone called Michael Gove, who was Secretary of State at DEFRA at the time, were very responsible for sort of something, and this is something called an SPF programme. I forgot what it is, strategic priority funding. Okay, which means that the work of the programme as a whole is designed to have that impact. That's what it's called SPF. So, and there were certain people in DEFRA who have been really influential from the outset. People like Tom Murray, Mayor D'Souza, and others, and they'll be around over the next 2.5 days because they're embedded in the work of the centres. So I think they're arriving either tonight or tomorrow, mob-handed. So they'll be around. But I just wanted to make sure DEFRA got acknowledged, and what that really sort of is to close the session is that the programme is about really interesting, innovative research, as we heard in the keynote this morning. You'll hear some of this over the next 5 days, and 2.5 days, and you'll have heard some of it from our work. But it's the translation of that into practice, and the session we've just had, I think, illustrates that sort of very, very sort of cleverly and clearly, that we need to be able to move from those clever ideas into practice. Because, as Tom said, I don't know whether I'm angry anymore. I'm too old to be angry. I think I was an angry young man, believe it or not. But you need anger, you need passion, and we need to change the system that we all experience and we all think is probably not working for the benefit of of all of us. So I think what we're looking forward to now is the 5 centres showcasing their work. I think we forgot to say, there is a drinks reception this evening, which will be announced. If it hasn't been announced, it's a new programme, so we can relax then and now get to lunch. So that's all I wanted to say. Yeah.
Okay, thank you, Peter. So it's now time for lunch. Lunch will be served in the main foyer where you've been having tea and coffees. There is an Innovate UK workshop over lunch as well. So this workshop is showcasing some of the CR&D projects that have been funded through Innovate UK. And this workshop is particularly focusing on decision-making tools. So that's going to take place in the building just opposite this building. So there'll be people to show you where to go. But we'd really encourage you to attend that workshop and hear from these fascinating projects. Feel free to grab your lunch and then head over there for that 40-minute workshop. And then after lunch in the workshop, we will be reconvening in here with the Met for Tech Centre, who will be kicking off just shortly after 1:30. So thank you very much. Enjoy your lunch.